Let's find some Laplace transforms of some functions. Um, of course, we'll be utilizing what we have learned, that is Laplace transforms of some elementary functions. Okay, let's look at the first one. Let's say the function is t square minus 1. Very straightforward. The Laplace transform of f of t is equal to Laplace transform of t square minus 1. And remember, we can take it separately. We know what this is. This is 2 factorial by s to the power of 2 plus 1, that is 3, minus, we know this is 1 by s cube 2 minus s square. So that is the Laplace transform. Okay, let's look at the next one. The function is f of t of 1 plus t cube. Okay, we have to find the Laplace transform of f of t. Okay, so this can be written as Laplace transform of 1 cube plus 3t plus 3t square plus t cube, and this we can split it. 1 plus Laplace transform of t plus 3 times Laplace transform of t square plus Laplace transform of t cube. This we know is 1 by s. 3 times, this is what? 1 factorial, power is 1. So 1 factorial by s to the power of 1 plus 1, 2, plus 3 times, this is going to be what? This is going to be 2 factorial by s to the power of 2 plus 1, 3, plus this would be 3 factorial by s to the power of 3 plus 1, 4. Okay, now let's add them all up. S4, this would be S3 plus 3s square plus 6s plus 3 times 2, 6. So that is the Laplace transform of 1 plus t cubed. Okay, let's look at the next one. Now the next function is f of t is equal to a plus bt the whole cubed. Again, first expand it off. A cube plus 3a square bt plus 3a b square t square plus b cube t cube. Okay, so the Laplace transform of f of t would be a cube, we take it out, Laplace transform of 1 plus 3a square b Laplace transform of t plus 3ab square Laplace transform of t square plus b cube Laplace transform of t cube. I'm sure you got the idea now. A cube Laplace transform of 1 is 1 by s plus 3a square b. Of t it is going to be, power is 1, so 1 factorial by s to the power of 1 plus 1, that is 2, plus 3ab square, it is 2, so 2 factorial, that is 2 divided by 2 plus 1, 3, plus b cube 3 factorial by s to the power of 4. Again we just add them up. So what do we get? A cube s cube plus 3a square b s square plus 3ab, no, not 3, 3 times 2 is 6, ab square s plus 3 to 6, so 6b cube divided by s to the power of 4. That is the Laplace transform. Now that you have got the idea of this, if it was square, accordingly, let's say f of t is equal to a plus bt square. So this would be what? A square plus 2abt plus b square t square. So Laplace transform of f of t would be a square. You can skip a step also if you are very comfortable with it. A square by s plus 2ab 1 factorial by 1 plus 1 2 plus b square by 2 factorial, that is 2 divided by s cube. S cube a square s square plus 2abs plus 2b square. Okay, now let's look at the next one. Let's say f of t of e to the power of minus 3t. Remember, this pattern is f of e minus st or minus at or kt, whatever, minus at, and this we know is equal to 1 by s plus a. So here what would it be? Laplace transform of f of t would be equal to 1 by s plus a. A is what? 3. So 1 by s plus 3. Okay. F of t is equal to 1 plus e to the power of t square. Again, expand it off. So 1 plus 2et plus e to the power of 2t. Laplace transform of f of t would be of 1, it is going to be 1 by s plus of e to the power of t would be 1 by s minus 1 plus 1 by s minus 2. Now add it up, s times s minus 1 times s minus 2, and this would be what? S minus 1 times s minus 2 plus 2s times s minus 2 plus s times s minus 1. S square minus 3s plus 2 plus 2s square minus 4 minus 4 minus 4s plus s square minus s divided by s times s minus 1 s minus 2. This would be equal to, we have a square here and square here. So 1 2 3 4, 4s square, and then s is minus 3s minus 4s minus s, so 7 plus 8, 8s plus 2 divided by s times s minus 1 times s minus 2. Okay, or the next one, seventh. Now a little bit tricky one. Let's say the function is 4 to the power of t. Now what do we do with this? The trick is to somehow get e. If you can bring in e, things become easier. So if I put e, I need to cancel this e or neutralize e. So log of 4t, yes, which can be written as e to the power of t. We can bring it in front. So this would become log 4 times t. Normally we put t in the beginning, but I want to follow the same pattern. So that's why I'm keeping it afterwards. So which means the Laplace transform of f of t would be e to the power of at. Remember, this is what? This is 1 by s minus a. Now here a is log 4. So log 4. Okay. 8. F of t is equal to cos 2t. We already know this. f of t is equal to, for cos mt it is what? For cos mt it is s by s square plus m square. So m is 2. So 2 square is 4. See, the better you know the elementary Laplace transforms of elementary functions, the faster you will be able to do this. Okay, let's say the function is f of t equal to sine 2t. So the Laplace transform of f of t would be, now this is, remember, m by s square plus a square, that is 2 square, that is 4. F of t of is equal to sine square t. Now we know sine t, we know sine mt, right? We know cos mt, but we don't know the square of sine t. So it would be better if we can convert it into cos 2t or sine 2t. Okay, let's convert it into cos 2t. That would be 1 by 2 times 1 minus cos 2t. Okay, so which means Laplace transform of f of t would be the Laplace transform of this itself. So this can be written as Laplace transform of 1 minus Laplace transform of cos 2t, which is equal to 1 by 2 times 1 by s minus, and this is what? This is s by s square plus 4. Okay, let's simplify this. S times s square plus 4, and this becomes s square plus 4 minus s square. So s square get cancelled. Only 4 is left, so we can cancel this. So we end up with 2 by s times s square plus 4. 11th one. Let's say f of t is equal to sine square of 4t. Yes. So now what will happen? The main thing is to get it into some kind of elementary operations. So in the previous example itself, we have seen we converted sine square t to this. So what we'll do is we'll again convert this to 1 by 2, 1 minus cos 2 of 4t. Let me put it as a square bracket. So which means this becomes 1 by 2, 1 minus cos 8t. So which means now the Laplace transform can be written as 1 by 2 Laplace transform of 1 minus Laplace transform of cos 8t. 1 by 2 Laplace transform of 1 is 1 by s minus, this is s by s square plus m square, that is 8 square, that is 64. Okay, let's simplify now. S square plus 64 minus s square by s square plus 64 times s. S square gets cancelled. 232. So we end up with 32 by s times s square plus 64. 12th, Laplace transform of, this is pretty straightforward. You can literally do it without, by skipping certain steps, some steps. So this would be 2 factorial by s to the power of 3 minus 3 times 1 factorial by s square plus, this would be what? 5 times Laplace of 1. So that is 5 by s. This would be now s cube. So this becomes 2 minus 3s plus 5s square. Or if we rearrange this, this will become 5s square minus 3s plus 2 by s. 13th one. Laplace of cos 3t sine 2t. Again, here, to solve this type of problems, you have to know the trigonometric identities. Yes. Okay, the associated identity would be sine A cos A sine B. This would be equal to 1 by 2 sine A plus B minus sine A minus. Okay, so let's apply this here. What will we get? 1 by 2 Laplace transform of sine A plus B, that is 5t, minus sine A minus B, that is t. So 1 by 2 Laplace transform of sine mt is what? That is going to be m by, that is 5 by s square plus m square, that is 5 square, 25, minus, again here m is 1 here, so 1 by s square plus 1 square, that is 1. And now we just simplify it. So s square plus 25, s square plus 1, 5s square plus 5 minus s square minus 25, which would be 1 by 2 times 4s square minus 20 by s square plus 25 s square plus 1, and 1 by 2, 4 we can take it out, so this becomes s square minus 5 by s square plus 25 s square plus 1, so this becomes 2 2's, so we are left with 2 times s square minus 5 divided by s square plus 25 s square plus 1, right? So as you might have noticed, in some cases you might have to know the identities, right? Whether it is related to algebra or trigonometry, or you know you have to know those identities so that you can convert the given function into a combination of elementary functions. Okay, so that way it would become, very easy for you to figure out the Laplace transforms. I think that's enough for today. Bye for now.